Alrighty, moving on to Unit 2. This, I always say this, but I love this stuff, some linear equation fun stuff. So here we go. I've certainly mentioned before that math is always the study of patterns, and that's how we're going to look at this. We're going to start a discussion of linear functions, and graphs eventually, as patterns, because it literally is a pattern. A couple of words you need before we begin. Independent variable. That's a variable that provides the input values of a function. You'll see in a bit, this is obviously going to be a function. And we have input, and that's the independent variable. Then we'll have output, that's the answer, so input and output here. And that'll be the dependent variable. But again, we're talking about independent variable. That's the input, that's the x's. So lots of different names for kind of the same thing. Dependent variable, the variable that provides the output values of a function. In this case, it's going to be y. So y is the dependent variable. What answer you get for y depends on what you put in for x, the independent variable. That's where we get that from. So in this case, input, that's a value of the independent variable. So the numbers you choose, the x's you choose to put in. So you put them in here, and out comes the y's over here. So again, notice here's my x's, here's my y's. The inputs are the x's, the stuff you choose to put in to get the output, which we'll talk about here in a second. So output is a value of the dependent variable. You solve to find this value. You think about, you've seen the function machine picture before, I'm sure. Independent, that's your x's go in, right here. And out, you have a function here, out comes the y's, right? So there you go. A function is a relation that assigns exactly one value from the output range to each value in the input range. These are graphical examples of functions. We have other relationships that aren't considered functions, and I'll show you those here in a second. But a nice straight line here. This one is also a function. We'll also talk about one-to-one functions. This is a one-to-one function. This is not. But they are both functions. So non-examples of functions, we're going to use something called the vertical line test. And if I hit more than one spot when I run a vertical line, when it's graphed, it's not a function. X equals 4, by the way, is not a function because it itself is a vertical line. And you'll have one x assigned to a whole bunch of y's. Let me remind you what that looks like, just out of curiosity. So if I had a graph, it looked like this, and I graphed x equals 4, that's about 1, 2, 3, 4, about here. It's a vertical line going up and down. So this one x is assigned to infinitely many y's going up and down here. So that's why it's considered not a function. This graph here, if I run a vertical line, it hits 2 spots, so therefore it's not a function. But they are relationships, most certainly, but these are not functions. And a linear function, that is a function whose graph is a non-vertical line, notice I stated that in the last slide, or part of a non-vertical line. So, nice example here, y equals negative 2x plus 4, and soon you'll be able to dissect this whole thing. You'll be able to tell me the slope here is negative 2, that with the y-intercept is 0, 4, and you'll be able to calculate the x-intercept and things like that soon enough, just from looking at this, and you'll know them in just seconds. So, but again, a linear function is a function that creates a line.